Next person I would like to invite and introduce you to is Łukasz Kudyba. Łukasz is at U2I for over 6 years. He can correct me later if I'm wrong, but I think whole 6 years on SCR. And when he's not busy with the usual U2I stuff after hours, he's actually very passionate about lifting heavy things. And today, Łukasz will share with you what we've learned by using Sidekiq with this data heavy, also heavy project. So welcome, Łukasz. Enjoy.
Cool. Hello, my name is Łukasz. I've been working at U2I since 2016, almost 6 years. That includes more than 5 years of building SCR, about which Przemek already said a couple words. He said about the data quality side of the product. I'd like to focus on the development side, the developer experience, and the tools that help us deliver value quickly and efficiently. One specific tool, which is Sidekiq. As Przemek showed on the horribly simplified diagram of our system, I will be talking about the top part. Just to set the stage for the next parts, a couple of questions. Who is using Ruby daily at work? Please raise your hands. Okay, a couple of you. Good. And who of you uses or has used Sidekiq ever? Good. So I hope I can provide something of value for all of you. Just a quick note, I will be talking specifically about Sidekiq because that's what we're using in our product. And Sidekiq is, a Ruby program. But if you don't use Ruby, don't worry. There is a language agnostic counterpart called Factory with a K, written by the same person with similar principles in mind, just a slightly different internal architecture. However, like most of the things I'm going to say, besides things Ruby specific, will apply to Factory as well. Okay, so just to give you some sense of structure, I'm going to begin with a very short, high-level overview of what Sidekiq is, what it can be used for. Then I'll reiterate on what Przemek said about our product, what technical challenges we are facing at SCR, and then how Sidekiq helps us overcome them. And then, if we have time, I will quickly show you what to keep in mind when writing your own jobs, what to look out for, and we will wrap up with a couple minutes for Q&A. Cool? Okay, so what is Sidekiq? As this page that most of you probably can't read now, it's a simple, efficient background processing for Ruby. It is a gem that you can just install in your Ruby or Rails application. You can use it directly in your code by writing a simple Ruby class and including one module. Or in your Rails app, you can use it as a default active job adapter. To me, Sidekiq basically is like a next step in the development of background processing frameworks for Ruby. Some time ago, the best we probably had was delayed job. That was one of the first frameworks that supported persisting your job data. And if you have an app that relies on reliability, it's a must. But it uses MySQL as a data store, which, it doesn't have built-in queue support and isn't very efficient for such tasks. So then Rescue was built, which moved from MySQL to Redis, with all of its benefits like exceptional speed, queue support, and atomic operations. And then about 10 years ago, I think this January, there was actually the 10th anniversary of the first commit. Sidekiq was released. It was heavily inspired by Rescue, also using Redis. It was inspiring to the point that the internal representation of a job was supposed to be compatible with Rescue, so you could use Rescue in production and then maybe try out Sidekiq with your existing queues. The main difference between Rescue and Sidekiq is that Rescue was single-threaded and Sidekiq leverages multiple threads per process, which in certain situations, like in ours, can give you a significant performance boost. In which situations I will get back to it. One more thing, the name, which I think is quite telling, comes from the notion that Sidekiq was supposed to be, well, a sidekick to your Rails app, like Robin to your Rails Batman kind of sidekick. I think it will become quite interesting when you take a look at how we use Sidekiq at SCR. Okay, so just quickly, once again, I am working on SCR, or social content ratings, which is the social engagement and video performance measurement solution trusted by the world's biggest media and sports brands. As you can see from the picture, we provide insights based on social activity from Facebook, YouTube, Twitter, and Instagram. And if I was to describe like the essence of the product, of the collection part, it will be something like generating engagement metrics based on an ongoing measurement of social activity. But since we're at a tech meetup, I'll try to translate it to more technical terms. So what we do is basically we collect social activity data by making hundreds of requests per second to external APIs, and then calculating engagement metrics from the data. And it turns out Sidekiq provides, I would say, significant help in making it all possible. Well, not only possible, but also quite easy. So let's try to dissect this challenge and see how exactly Sidekiq helps us. So let's start with making hundreds of requests per second. I think the main advantage of using Sidekiq is that it scales well, and I'd say it scales with minimal operational effort. Up to some point, of course, you can outgrow Sidekiq, but that probably means you're dealing with a much bigger volume of data, something that requires much more complex architecture than what we're talking about here. So let's say we have a Rails app, a simple Rails app that does some background processing. It can be sending an email in the background, image processing, let's say, or generating an Excel report. It's what we do a lot of in our system. And you may start with a single Sidekiq process running on a single CPU core, and that would probably be enough. But what if you need more? Actually, we need quite a bit more. So we've got a couple of options. Here, you can't actually see, probably, the dashboard from one of our production apps. This is an app that handles Facebook data collection, and it uses like multiple levels of scaling with Sidekiq. The first level is just having a process with multiple threads, which helps, but because Ruby has this mechanism called global interpreter lock, it doesn't actually let you use more than one CPU core at the same time. I'll say something about more about it later. So in order to use all of our cores, we're running multiple processes. Here are like 4 processes running on the same machine. And if that's not enough, or you don't want to rely on a single machine, because you usually can't, if it fails, everything fails. So you want to add another machine. And like you can see here, we have 3 different EC2 machines running Facebook collection. Each of them has 4 processes, and each of the process uses multiple threads. So how can you achieve it? As I said before, scaling with Sidekiq is quite straightforward. If you saw my bio from one of the posts promoting the event, I said that I like to ask myself, what would it look like if it was easy? And I think Sidekiq scaling is a very good example of that. I would rate it very highly in developer experience. So with Sidekiq Enterprise, which is the paid version of Sidekiq, which costs like $200 a month, you get an additional program, a binary called Sidekiq Swarm, which controls your Sidekiq setup. And thanks to that, you can set the desired number of processes and threads using just like environmental variables and parameters to this program. So that's scaling Sidekiq on one machine. And if one machine is not enough, you just spin it up, deploy your application code, and point your Sidekiq workers to the same Redis instance. And then the Sidekiq workers start processing the jobs automatically. They pick them up from the queues and start processing them. And this is kind of a framework, I would say, we use for scaling, but not only like scaling within a single app. We use it for scaling like the business horizontally by adding more and more social media platforms. So like when we had just 3 platforms and there was a need to add, let's say YouTube, it was actually like an architectural no-brainer. You just create a simple Ruby app with just a handful of API endpoints to communicate, and like let Sidekiq do like 99% of the processing. You just create a schedule for jobs using something that looks exactly like the Linux cron, and you're happy. So with our like this framework for our apps that we use for scaling, and giving Sidekiq like 99% of work, I would say Sidekiq is more like a protagonist for us. So how has this approach been doing? We've been using this architecture for like 5 years now, adding more and more social media platforms along the way, increasing the requirements for the number of jobs processed per second, the requests we make to the APIs, with our daily peak of Facebook collection at like 700,000 Facebook posts collected in a time span of like 5 to 10 minutes. And I think when you combine it with what Przemek said, with our certainty that almost 100% certainty that we don't introduce bugs, I think a good symptom of our success is that most of the failures we experience in the system actually come from the failures on the API side. Sidekiq just works, and you can sleep well at night. So that's it when it comes to scaling. Now back to our technical challenge. And that's the specificity of the actual operations we are doing. And those are synchronous requests to external APIs. Now this is something about Ruby I definitely learned too late in my career. When I earlier said that Sidekiq strength, which is multi-threaded processing, shines only in certain situations. This is what I meant. So you can't see anything, but a single Ruby process with the global interpreter log will only execute one thread at a time, even if we create multiple threads in our code. However, there is one single case where this mechanism is actually useful, and that's waiting for I/O. It can be a DB query, reading a file from a disk, or synchronous HTTP requests, just like in our apps. So then, when you have multiple threads, when one thread is waiting for I/O, which is here, another thread starts processing. And given that our jobs spend most of their time, or at least like 50% of their time, waiting for the responses from the API, I would say this design fits our needs perfectly. For I/O-bound jobs, this is extremely beneficial. Of course, as long as we stay within the Ruby bubble, especially compared to Rescue. I am aware of the fact that we have modern programming languages that can handle parallelism. That's a different topic. So one last thing about external APIs. When you're dealing with APIs, you can be basically 100% sure your request will be failing for no reason, especially if you're dealing with Facebook. So what to do is just let Sidekiq handle it. When a job throws an exception within Ruby, it just gets retried a couple times automatically. You don't need to do anything. And if it keeps failing and it exhausts its available retries, you just I highly recommend to just add some code that, let's say, sends you a pager when it was a critical job or a Slack notification. So that's it. With Sidekiq, you just add one class and you get the job details, and the error you can handle it yourself. And the last part of our technical challenge, which is calculating engagement metrics from the data. There are two distinct parts to this, I would say. One is calculating, by which I mean running CPU-heavy operations, and from the data, which means after the data is collected, like the operations are not urgent and can be done like in the background to the background. So let's start with the latter part. Once again, Sidekiq makes it easy out of the box. Your jobs don't and shouldn't have live in the same queue. Just have multiple queues with different priorities and let Sidekiq handle it. As you can see, we just have a handful of queues from super high priority to like low priority and default, whatever that means. I know of some companies that have a much more complex setup. One of them, I don't remember the name, but they had queues named basically by SLAs. So they have like a 1-minute queue, 30-minute queue, an hour queue, and jobs in your 1-minute queue should be processed within 1 minute. So what you do, you just add some monitoring to the latency of your jobs, and if they take more than 1 minute, you scale up, which is with Sidekiq is easy. The other thing is calculations, and what I mean by this is processing that's not I/O bound, but rather CPU bound. And if you're running 10 threads per Ruby process, for example, each of them spending most of their time using the CPU, it's going to be exhausting for your machines, and you won't get any benefit from multi-threading. So we are slowly migrating away from Sidekiq with such tasks, mostly to AWS Lambda, about which I think Marek talked about at the first UTI meetup. So yeah, we leave I/O bound processes IO-bound tasks for Sidekiq. Okay, so that's how we use Sidekiq at SCR. I hope it made at least a little bit of sense. So now a couple of lessons or suggestions. If you're maybe interested in and you would like to try out either Sidekiq or Factory. So first thing is that if you want Sidekiq to work properly, you as a developer need to cooperate. There's no such thing as a free lunch. In this case, what you need to pay with is what I think of an exceptional development discipline when it comes to writing your Sidekiq jobs. So prefer running 5,000 jobs that take a second each than a single job that takes an hour. You will likely avoid memory bloat and you'll take advantage of the concurrency. Write idempotent jobs. Sidekiq only guarantees that they will be run at least once, not exactly once. And write code that is thread safe. After many years of the presence of Sidekiq and Puma, two of the biggest open source Ruby multi-threaded applications, I'd say most publicly available gems are thread safe, but your code needs to be thread safe as well. So, embrace statelessness, immutability, and don't use global variables. The second thing is Ruby is still Ruby. While our use case, I think, maneuvers really well within its limitations, it doesn't mean Sidekiq and Ruby is great for everything. And the last thing, simplicity is the ultimate sophistication, as always. From my experience, like the trickier your solution, the higher the chance something breaks. So I think Sidekiq embraces simplicity really well, but not with all its features. Just try Sidekiq batches. Every time I am writing a Sidekiq batch, I feel physical pain. So can't recommend yet. And yeah, that's it. Here you have a cut. And I hope those 20 plus minutes brought you at least one valuable thought, one sentence that made it all worth your while. And yeah, if by any chance I cured your chronic insomnia, just let me know. And yeah, thank you. And if you have any questions or comments, just let me know. Now is the time. Okay, there's one question.
Hey, thanks for the presentation and the cat's picture. I have a question. How do you scale your Redis instances?
That's the question. Okay.
Yeah.
Yeah. So we
first.
Yeah, thanks. Yeah, a very good question. We actually Redis by itself can handle 20,000 jobs per second. So it's quite a lot. That's definitely enough for us. But you have multiple options. One of them is using Redis sharding, where you can have multiple Redis shards and your multiple servers connect to a couple of them connect to one shard. So you can have tens of thousands requests per second with Sidekiq and Redis.
And does it support any other backends other than Redis?
Sidekiq supports only Redis. As I said, it embraces simplicity, and with its very opinionated creator, Mr. Perham, it won't. It will never support any backend, and I don't recommend asking for it. However, you could always use Factory, as I said. I think it doesn't even use Redis, and it handles all the operations itself. So it has a bit more advanced architecture. So if you need this, if you don't like Redis, you can try Factory.
Okay, and about the threads, because you've mentioned that Ruby has global interpreter lock. So how does it work that the threads are supported? I didn't get it.
Yeah, so you basically get threads because you can share memory, and it's cheaper than processes. So, and the global interpreter lock is actually a limitation. So you can have like 5 threads, and then they will be executed, all of them. But you can only benefit from the parallelism if they are waiting for I/O. So,
but technically, do you need to like do some magic, or it works out of the box in Ruby?
No, it's how Ruby works. If you create threads, they will only be executed if another thread waits for I/O. That's how it works.
Okay, cool, thanks.
Any other questions? No, cool. Well, thank you once again, and that's all.